and this is also the last time, because the best I can do is stretch 800 by 600 resolution. But at least you get large text. So I'm going to talk about the missing link in single-page web applications. And page is sort of a horrible word. It means a lot of things. So I'm just going to define what a single-page web app is, because if you haven't made one, the page term makes it kind of hard to understand. So typically, single-page web apps means no page reloads. It doesn't mean that your application just has one view, like the to-do list application. It's just one page, the to-do list. You can have sort of multiple views or pages, if you will. And therein lies the problem of the pages word. It can mean a lot of things, but you never sort of change. You reload the page at the browser level. So if you use Gmail, this is how Gmail works. You go from the inbox to the to the spam to settings. You sort of go from part to part in the application, but the entire web page doesn't reload. You might think that Gmail has a fallback, but it doesn't. So the HTML mode in Gmail is actually a separate application, which sort of looks like the normal Gmail. But the normal Gmail is completely no fallbacks, no progressive enhancement or graceful degradation, just JavaScript doing everything. So that's single-page web apps. So since I'm talking about the web as an application platform, I thought I'd start by debunking a couple of myths. This is what everyone says, right? The web was not made for building applications, and the logical conclusion is that the web sucks for building applications, right? And in a way, they're right. The web wasn't made for building applications. It was made for documents, going from page to page, hyperlinks, all that jazz. So let's take a look at the native application frameworks and take a look at what they do. I have never heard an iOS developer complain about how terrible it is to make a native iOS application. Quite the contrary. So obviously iOS, the frameworks you have there, are great for building native or for building applications. So I'm going to look at three frameworks, iOS and Android and Qt. iOS because I know it. I made some native iOS apps, and Android and Qt because they're other application frameworks. I don't really know them. So if I say something that is blatantly wrong, you are free to correct me, of course. So there are three things that are common to all of these native application frameworks. The first of which are views. So they all have a concept of views, and views are in a tree structure. This is an iOS example of that. So here you can see some code that creates a red view, and it creates a blue view, and it adds the blue view as a subview of the red view. And there you see those two little views below there. Because the blue view is a subview of the red view, it is rendered on top of the red view. Most of you probably understand this. Because it's iOS, we also have to say clip to bounds to false. If not, the blue view would be clipped outside of the bounds of the red view. So this is, of course, common to all three. On iOS, you have UI view. You can add subviews to UI view. Android and Qt are slightly different. You can't add subviews to a view. You have a separate thing called a view group in Android, graphic scene in Qt. So you can, of course, nest graphic scenes, but it's basically the same thing, right? You end up with a tree structure of views. So that's number one. Number two is events. So all of these native application frameworks can listen to events on the view level. So each individual view receives events and handles them. So on iOS, you can subclass a view and override touches began, touches ended, and so on. You also on iOS have a higher level API, gesture recognizers. So you can add a swipe gesture recognizer to your view. It's basically the same thing as touches began and touches ended, except that the logic for detecting whether it's a swipe or a tap or whatever is built in. Same with Android and Qt. You can subclass it and override some methods, on touch event, mouse press event, etc. Third thing that is common to all native application frameworks, at least these three that I'm talking about, is that events bubble upwards in the tree of views. So here are two views. If I'm on an iOS device and I tap that blue view, the blue view will receive events for that, and also the red view. So that's what I mean with events propagating upwards in the tree. So if I do a swipe on the blue view and I have a swipe gesture recognizer on the red view, it will still trigger, even if the blue view is on top of the red view. So, tree structure of views. Views listen to events, and events propagate up the tree. So, are anyone seeing where I'm going with this? Have you seen this before, maybe? Let's just change some of the words here. As we see, it's the same thing, right? This is exactly how the web works. So, we have a tree structure of DOM elements. DOM elements listen to events. Events propagate up the tree. So clearly, the argument that the web isn't that the web sucks for building application doesn't hold so far, because as we can see, it's identical to the native application frameworks. Works exactly the same way. So we have element or DOM elements. You have the add event listener in the DOM. So same thing. However, there's a fourth thing that all of these native application frameworks have, which is sort of higher level managing of multiple views. So in ways that are useful to typical patterns in applications. So since I have some first-hand experience with iOS, I'm going to just briefly sort of introduce you to how iOS handles this. So a little bit higher level handling of views. So in iOS, you have something called a view controller. Basically, its purpose is to do everything about views except from the actual rendering. So you make subclass of your view controller. Then you sort of tell your application to display this view controller. And the view controller is sort of one screen in your application. And the view controller has one view, exactly one view, that fills the screen. And then you can add subviews, of course, to that view, because it's just a normal view. And all adding of subviews is done in your subclass of the view controller. So you might have a couple of text fields, and the event handling for those text fields are handled in your view controller. So a view controller is basically handling everything that needs to be handled for a view on a single page in an application. It also does memory management and lifecycle and other useful things. So on top of that, there's a navigation controller. So you can tell your application to, at the top level, use a navigation controller. And you also have to set a root view controller, which is the first view controller that will be displayed when you open the application. So what you can do is that, so the one on the left here would be our first view controller. It has a bunch of views. It's the background, the color thingy. There's the three cells. That's all part of the root view controller. And what happens when you tap one of those buttons, for example, general, you will receive an event. You will handle it in your view controller. And what you'll do is that you'll create another view controller for the next page you're going to go to. Then you're going to tell the navigation controller. It's like an array-like API. So you say push view controller. And then iOS will handle basically a lot of things for you. It will do the animation transition thing. You'll get, as you can see here, there's this back button, kind of hard to read, but you get the back button to go back to the previous page, and all of those things are handled for you. So this is an example of higher level utilities that native application frameworks have that sort of helps you manage views in ways that are useful to applications. So, of course, I don't know the particulars of Android and Qt and Windows Phone and desktop Windows and desktop Mac because I never used them, but I know that Android has similar abstractions. I guess the other ones have. iOS has it at least. Of course, on the web, what do we use to do this? Well, of course, there's nothing really built in to do that. So the low-level parts, the views, the tree structure of views, the event handling, is common for the web and native applications, but there's nothing built in on the web for these higher-level things. So I'm here today to talk about the missing link, which is, of course, the web's answer to this step 4 for higher-level handling of views. I'm calling it navstack.js, and it solves these 3 important problems. So you have to go from page to page, and I do that in a way that's similar to the iOS view controllers. But the fact that Pages has URLs is not the case on iOS and most native application frameworks, right? But the web has URLs, so that's important. So when you build your tree of pages or go from page to page, you need to make sure that the pages have a URL, right? And also, this is the most important part, and this is the actual missing link, is that you have to reconstruct your page from that URL. And that's, of course, if you have a URL, it's no point having it if you can't use it to reconstruct your page. And some of you might be thinking that, well, there are frameworks out there to fix this 4th step, the missing link, the high-level handling of views on the web. But the problem is that they don't do it right. And I'm going to show you how to do it right. So I made a little demo app that uses Navstack. And I'm making an application, a single-page web application at work. It's about events and event attendees. So here I have sort of a boiled-down version of that. So we have a list of events, and I should go out of full screen now so you can hopefully see this URL at the end. When I click an event, you see I go to that page, and unfortunately my resolution is kind of low. You can sort of barely see it there. Well, it says / and the ID of the event. That's what it says. And when I click one of these tabs, the URL also changed. So now we're at / the ID of the event and / tab-arrived. So I can now reload this page, and the page reloads in the correct state, right? The arrived tab is active. We see the arrived attendees listed. And since this is a single-page web app, we have the sort of possibility to do partial page updates, right? So just to show that when I click these tabs, I don't reload the whole page. So I can just select this text, for example. If I did a full page reload or replaced all the DOM elements, that text selection would be gone now, but it stays, right? Because I only update this part of the page, and the URL also changes so that when I reload the page, I get to the correct state. Well, so you've probably seen this kind of construct, right, for handling URLs in web apps. I know that Backbone does this, probably other frameworks too. And this is basically a port of how you do it on the server, where you respond to one URL and then you do something for that URL. So routing, you know. And this is, as I said, it's a port from what you do on the server. And the server is kind of different from single-page web apps because you load the entire page every time. You don't have these partial page updates that I showed just right here, where you don't update the entire page, right? So if I were to use this method, I am not, but if I were to do it, so when I get to events / ID of the event / tab and then the name of a tab, I have to do different things depending on whether I click the tab or load the tab from the URL. So when I refresh the page now, you can see that it loads the back button, the header, the other tabs, and then the content for that specific tab. So if I used just manual URL routing now, and I didn't do anything special, I would either have to update the entire page when I change the tabs, or you would get like, when I click this tab here, you will get the entire web page, right, copied, because that's what it has to do when it loads the page from the URL from scratch. So I would need to manually sort of take into account that you could also click this page manually, and then I shouldn't load the rest of the page. I should just load, right, the contents of the tab, right? And that's exactly the kind of problem that NavStack solves. And I'm going to show you how it solves that. Because I can tell you right now that I don't have any special code for handling it, and that's sort of the point. So the way NavStack, the way you write pages in single-page web apps with NavStack means that you don't have to handle these cases separately. So is this readable? Good. So this is my single-page web app. This is all the HTML. First, I load NavStack itself, the framework. Then I have a bunch of pages. So now we'll learn a little bit about NavStack. We have something called a page in NavStack. Then I have a table view, and I have some mock HTTP, and some init. So I'm just going to show you the mock HTTP first. My lines are a bit too long here, but basically what it does is that it creates, you know, a random list of names. And then I have this get, myapp.get, which is my mock HTTP thingy, which actually just does a switch on the path, nothing fancy, and returns data. So for /events, we return a list of events, etc. And then we also do that inside a set timeout, just to make it asynchronous and sort of behave like network does. All right, so that's sort of the structure here. Let's look at the initialization, my app.init.js. So this is where things get started. So first I have to create an instance of NavStack. Personally, I prefer those kinds of libraries instead of having an instance made for me. I will never actually use multiple instances, but I like to, you know, have the control. So we create our NavStack object, and then we have to give it a root page. So it's able to do, if you don't give it the root page, it will just fail miserably. And the page can be any kind of object. Here I'm using a constructor. You can use object create. You can just inline it. Doesn't matter. Doesn't have to be a special NavStack page, a subclass thingy or whatever. It's just an object. The only sort of requirement is that it responds to specific properties, as we'll see later. I also have to set the target of my root page, which is the DOM element that my page will live in. If you go back to the HTML, you will see that this is this div here, div ID app. So that's where my page will, or all the DOM elements for my page will be. I'll talk about these two, or 1, 2, 3, 4 lines afterwards. First, we'll just take a look at what our root page does. So this is the root page, the list of the events. There are some properties that NavStack will call on your page if they are set. One of them are prepare. So the page that lists the events basically can't do anything unless it has the list of events from the server, right? So that's the purpose of prepare. NavStack won't render anything until your page is fully prepared. And it's also asynchronous. So as you can see here, we give it or a function. Done is a function that is passed into prepare. And then when you call this function, you tell NavStack that you're done loading. So just to show you, I can put this in a timeout, for example. And now nothing will happen until done is called, right? So that's the purpose of prepare. And when you have sort of a cascading list of pages, it will prepare the one before the other and so on. So that NavStack guarantees that your pages always have the data that you require them to have with this prepare callback. The next one, create element is also a method that Navstack will call on your page. It's also required to have it. And what you have to do there is to return a DOM element. Here I'm just using the DOM API. You can use whatever you want. You can use Mustache for templating or Serenity, which is kind of recent, which is also a good templating engine. It doesn't matter. All you have to do is to return a DOM element. You can use jQuery and pass it HTML. Just make sure that you give it .elements, .0, so that you get actually the first, the raw DOM element. It has to be a native DOM element that you return. So you can see what we do here is that I create the header. Oops, what did I do now? There we go. So I create the header, this guy, and then for each of the events, remember this events, I set this in prepare up here, right? So I'm guaranteed that by the time create element is called, I have this .event set on my page. And I just loop them and create a link for each of the events. And now, this is the interesting part. If we take a look at the click handler of these events, so we can see that we call go-to-event. And this is interesting. Look at what go-to-event does. It does not directly change anything in the DOM. It does not sort of reach out to the target of the root page and try to replace it with the contents of the next page. As you see, that's what ends up happening. You click this, and all of the old stuff disappears, and it's replaced with a new page. But we don't actually do that in our click handler. What we do is that we call out to our instance of Navstack, similar to how we would call out to our navigation controller in iOS. So my app.nav, just back to the init. That's our instance of Navstack, right? So we say my app.nav push path segment. And the path segment that we push is the ID of the event that we want to go to. So what happens when you push a path segment to the Navstack is that it will find the page that is currently on the top of the stack, right? The page that you're looking at right now. And it will ask that page for the next page. So the current page is always responsible for getting you to the next page. So what will happen is that Navstack will call route on your page. The path segment will be passed in. In this case, it's the ID of the event, right? Because that's what we pushed earlier. And then we just have to check that the event actually exists. And if it does, we return a new page, the attendance page. So here you sort of already get an idea of how this works. Because when I click this link right here to look at an event, or if I reload this page from the URL, the same code is called. The exact same code is called, right? And that's the point. So you don't do anything special in your click handler. You don't do anything special to load from URL. You just work with these path segments, and pages are responsible for routing to the next page. And this allows Navstack to do all the hard work of making it load from URL or load from button clicks or whatever for you, because it's the same code that's called, right? More interesting, when we do the partial updates that we do here, I just like to select the text to sort of prove it's partial, believe me, like a illusionist or magician or something. So let's look at the attendance page. So it also has this prepare thing. So the attendance page can't do anything before it has all the data for that event. Create element as well. I'm still using the DOM API. This is, of course, not specific to Navstack. You can use whatever templating system you want. So here's the back button, this guy over here. Here's the header, which has the name of the event. By the way, as a sort of nod to the previous talk, text content, learn that property. It will escape the HTML as opposed to inner HTML. And then we create the tabs. So we always have the all tab. The event specifies which tabs the event has. So if we check out strange loop, it doesn't have any tabs. So we get from the API. The API tells us which tabs it should have. And then basically this is just a hard way of saying that when you click a tab, what happens is that we'll call show attendance for tab and pass the name of the tab there. So let's take a look at what show attendance for tab does. Here it is. It's the same thing as before. We push the path segment. So we don't do any manual DOM work here. We just tell Navstack, okay, now we want to go to the page for this tab. So again, now the attendance page is at the top of the stack, right? So route will be called on the attendance page. So let's take a look at what route does. Here it is, route. And then we check if the segment starts with tab dash, because when we go to the tab arrived, we can see that the URL is, again, I'm sorry, it's hard to see, IDO event / tab dash, and in this case, arrived. So the name of the tab. So we check for if it's a tab that we're routing, then we use some regex to extract the actual name of the tab without the tab dash before it. Then notice that we activate tab. This call is what makes it gray, gives it a gray background. It's important to not do that in the click handler of the tab, because then it wouldn't be gray when you load the page from URL, right? So you have to sort of be a little bit careful about those kinds of things. So we only activate the tab when it's routed so we don't have to handle that specifically. And then, as before, we create a new page, the attendance tab page. And here's something interesting. We set the target of that page. That's what makes it a partial update. Because previously, when we go from the list, the root page, to the page for the event, you see that the whole page changes. We didn't specify that, but what Navstack will do is to, when you don't set the target, it will just go to the parent pages until it finds a target. And in this case, it will be the target of the root page, right? So that's why it replaces sort of the entire root page. But in this, for these tabs, we don't want to replace the entire page, right? We just do a partial update. So that's why we set the target on that new page. So with Navstack, you can nest that as much as you want and have as many targets as you want. And it'll work. And of course, if you're curious, this is a reference to a DOM element I'm creating in this big, huge, complex create element method. So I create the tabs here, append the tabs element, and then here I just create the attendance element. It's a div. I append it, and that reference is what I'm using in route down here, this attendance element. So because I do sort of most of the page transitioning logic in the routing or in the route callback, as we saw earlier, I don't have to do anything special, right, in order to achieve this partial updating effect. And that's sort of the main missing link and the big problem that Navstack, my library, solves for single-page web apps. Because as we saw, if we just did traditional route matching, full-page kind of thing, we would manually have to deal with all these kinds of different ways of getting to a page. Well, with Navstack, you don't have to deal with that. And I think that's important because it makes it really easy to make single-page web apps that has URLs, that can load your page from URL, and all sort of stuff. So that's good. So I have plenty of time left. However, recently, I don't know if you've seen this, Tom Dale and Yehuda Katz, they're the Ember guys. They made a blog post and a gist which explains how the new routing system is going to work in Ember. And it's kind of interesting because this is the rationale. The primary goal is ensuring that the code that runs when you enter a state programmatically is the same as the code that runs when you enter a state through the URL, which is exactly the same thing as that Navstack achieves. And quite frankly, I'm glad that someone else is picking up on this because, as they say, if you're the only person that have an idea, it's probably not a good idea. If it's an important problem to solve, someone is bound to come up with that as well, you know. So I was kind of worried here for a while. You know, I am the only person here that can sort of see that this is obviously the way to build single-page web apps. Well, thankfully, there are other people seeing it as well. So actually, for my project, I haven't really investigated Ember in detail yet. But because they are the first sort of single-page web app framework that does this, I actually might consider switching to Ember, so I don't have to write my own library for it. But Ember's approach is very different. You have to sort of predefine what your page tree looks like. I think I might be wrong here, but I think that's how it works. And so you can do what you can do in Navstack, which is just at runtime decide which page you want to push to, which path segment you want to push. It has to be predefined in Ember. And Navstack, of course, can be used standalone without Ember. Another kind of problem is that Navstack isn't released yet. I was hoping sort of to get it in release quality before this conference, but it's not. So if you look at an example here, when we route, we return nothing if we don't want to route, right? That's how we do 404. So we only return the attendance page if the event ID that is in the URL actually exists. But if you give it an ID that doesn't exist, you'll just get weird errors by undefined, does not have the property, It's basically not handled. So that's where Navstack is at. But of course, feel free to chip in if you want to make it happen. If you are making single-page web apps and need this, and you do, come talk to me. Well, if you get a developer preview or whatever, or perhaps I'll just put it up on GitHub regardless. Or you can, of course, follow me on Twitter if you really want to know when it's released. And that's it. Thanks for listening. So, are there any questions?